Hello. So today we have to discuss about the second part of universe. Already we are informing you GS physics course is started, right? In this GS physics course, for our first chapter we are taking as our universe. In our universe, what we are discussing? We are discussing about one thing. Which one? That is galaxies, cosmology, planets, everything we are discussing. But today we are going to discuss about in our universe how it is formed. Our universe is formed 4 billions years ago. But even though still our universe is existing, within this universe, what are the things are there in this planet, how the planet is acceptable for the living creature, supporting to live the animals and creature and everything, all these things we have to discuss. Clear? And then we have to discuss about the earth, how many layers are there in that earth, and how the life is evolved in this earth. Those things we are discussing in this class or in this video. Once you have to see, this is very important. Once you have to see our origin of the universe. What is our origin of the universe? How the universe is origin? How universe formed? Because of the Big Bang theory. According to the science, by Big Bang theory, our universe is formed. In Big Bang theory, long back, our universe, the Big Bang is a physical theory that describes how the universe expanded. How the universe expanded from initial stage of high temperature and high energy density. Initially, our universe is some like clumsy like this there, with high density of energy and high temperature is there. Which one is there? High density of the energy and high temperature is there. But what is the Big Bang? Big Bang means a big, whole thing is there. And bang, Big Bang, whole thing is clumsily solid and dense material is there. Within this dense material, high density of energy and high density of temperature and high pressure is involved in that. Clear? Once it is involved, that thing we call it as a Big Bang. Once again, you have to see the statement. The Big Bang is a physical theory that describes how the universe expanded from an initial state of high energy density and high temperature. For next, what we have to learn? We are learning about the cosmological evaluation of universe. Cosmological evaluation of universe. How universe is evolved? Now only I told. The universe is expanded from one time to another time. How is expanded? After some time I have to show to you. Our universe began with an explosion of space itself, the Big Bang, starting from extremely high density. Suppose you have to see, this universe is extremely high density universe. After some years, high density and temperature, the space is expanded. How it is expanded, you have to see. All the galaxies are forming. This universe going to happen into a infinite number of galaxies are there. Infinite number of galaxies are there. Within the galaxies, our Milky Way, our sun is one star in the Milky Way galaxy, that is the Akasha Ganga galaxy, right? Expanded in the universe, cooled. The simplest elements formed because of the gravity gradually drew matter together to form the first stars. This Milky Way, now I am coming into the stars, expanded again stars. So many stars are there. In our solar system, our sun is, in our solar system, our sun is energy of the source. It is a brightest star. In our solar system, the brightest star is sun, right? Which one it is? It is a Milky Way. Milky Way or Akasha Ganga. This is a galaxy. Again expanded into the stars. Again this solar system is expanded into planets, right? Expanded into planet, Earth, Uranus, Neptune, Pluto, like that. All the planets are there, moons are there, asteroids are there, comets are there. So many things are there. How they expanded once you have to see. Our universe began with the Big Bang. Before the Big Bang, our universe is clumsy with high energy density and temperature. Our universe is clumsy with high energy density and temperature. Right? Clear? That is the Big Bang. Now, cosmological evaluation of universe. How the cosmological evaluation of universe happen? First, universe is there. After expanding after some days, it cooled. This energy and density cooled. It can become as a Milky Ways. Infinite number of Milky Ways are there. After some days, it can transform as the stars. How many stars are there? Infinite number of stars are there. These stars in the sun, our solar system, if you have to consider our solar system, sun is the centric, right? To sun centric, so many number of planets are existing. This is the cosmologic evaluation of the universe. Now you have to see how the history of the universe. First, maybe in 10 to the power of minus 32 seconds, in inflection, inflation, initial expansion. This one we call it as a initial expansion. In 10 to the power of minus 32 seconds, there is a inflation is there. Our universe will become like this. After 1 microsecond, the first particle can form. After 1 microsecond, which one can form? The first particle. Neutrons, protons, electrons can form. This can form like this. After 3 minutes, the first nuclei can form. The first nuclei, this is the helium and the hydrogen can form. After 3,80,000 years, 3,80,000 years, the first light, the first atoms are forming. After 200 million years, the first stars, gases and dust condensed into the stars. Which materials are there in the stars? Gases and dusts are there. These things condensed into a star. Next, after 400 million years ago, galaxies and dark matter can form. These galaxies and dark matters form in the cradles. These are the galaxies and dark matters. After 10 billion years ago, the dark energy expansion accelerates. This is the dark energy. After 13.8 billion years ago, our today humans observe the universe. This is the universe today. After 13.8 billion years, today humans observe universe will be like this. Universe is expanded like this. Clear? So how universe is expanded? When the Big Bang theory will happen, so that time so much of heat, so much of temperature, so much of energy, so much of pressure, any creature, anything, any entity cannot withstand in that system. But even though days are going on, a cool thing will happen. After cooling the planets or stars, all those things, these solid materials are forming. Now universe is existing like this. The human beings also exist in the planet Earth. Right? Clear? Once you have to see. Life on the planet Earth. Earth is a planet so far known that supports the life. Earth only supports the life in our solar system. Already I told you in solar system class, in solar system, sun is a source of all the planets and moons, asteroids, comets, and dwarf elements also, planets also is there. Pluto, Ceres, like this dwarf planets also is there. Clear? For all those things, sun is a source. Sun is the major, like father, like that sun, right? Sun centric is there. But among all these things, which is supporting the life? Only one planet, that planet is Earth. Earth is a planet so far known that supports life. It is our home planet. Planet having air, water and other conditions favorable for the existing of life. For existing of the life, for existing of human beings, plants, animals, whatever it may be, you need water first. You need the soil first. You need the water first. You need the air, oxygen you need to live. All the animals, they breathe the oxygen. Plants, they breathe the carbon dioxide, right? These things, air is an essential. That's why in the planet, air and water and other conditions favorable for existing the life, right? Clear? So that's why life on the planet on Earth. Life on the planet on the Earth. Earth is a home planet to consider to support the life on the Earth successfully. Right. The rocky portion of the Earth is composed in 3 layers. I am going into the inside the Earth. First, the rocky portion. There 3 layers are there. The first layer we call it as a crust. The first layer we call it as a crust. The second layer we call it as a mantle. The third layer we call it as a core. The first layer you have to see. This is a crust. The first layer, whatever the surface layer is there now, this surface layer we call it as a crust. The second layer is a mantle. The third layer is core. Core is divided into 2 parts. One is the outer core, another one is the inner core. What are they consist? Each and everything we are discussing now. Once you have to see. First, we are discussing about the crust. Crust. What is a crust? Crust is the outer layer of the planet Earth. Crust is a outer layer of the planet Earth. There is a outer layer is there now. If you have to take the cross section of the Earth, the crust is a outer layer of the planet Earth. Outer layer of the planet Earth. The crust consists of mountains, lakes, plateaus, valleys, oceans, seas, rivers, etc. So the crust consists of how many things? Mountains, lakes, plateaus, valleys, oceans, seas and rivers. This crust consists of plateau, mountain, lake, valley, ocean, seas and rivers and etc. Already whatever you are observing today, you are enjoying the life, those things consist of the crust only. All these are surrounded by thick blanket of air called atmosphere. All these surrounded by which one? There is a thick blanket act as a atmosphere. There is a atmosphere also is there. There is a air surrounded by thick blanket of air. that thick blanket of air, we call it as atmosphere. The thickness of the crust changes from place to place, 5 to 12 kilometers under the oceans. If you have to see, under the oceans, 5 to 12 kilometers are there. Under the continents, the crust is 35 to 60 kilometers are there. This is very, very important. How many points we are seeing? This is the outer layer. Crust is a earth outer layer. It consists of a mountains, lakes, plateaus, valleys, oceans, seas and rivers. That is the first one. All are these surrounded by a thick blanket of air. The thick blanket of air, we call it as the atmosphere. The thickness of the crust changes from place to place, 5 to 12 kilometers under the oceans, 35 to 60 kilometers under the continents are there. 5 to 12 kilometers under the ocean, 35 to 60 kilometers under the continents are there. This crust consists of 3 rocks, majorly 3 rocks are there. Those rocks are ignite rocks, ignite type of rocks, and the second one is a sedimentary type of rocks. The third one is a metamorphic. Igneous, sedimentary, metamorphic. Igneous, sedimentary, metamorphic rocks are there. Suppose you have to see here, there is a crust. Crust is 2 types of the crust is there. Oceanic crust and continental crust is there. In oceanic crust, what is the width? 5 to 12 kilometers. In continental crust, 35 to 60 kilometers depth is there, right? So you have to observe this one. Now you have to see, it is made up of 3 kinds of rocks. Already I told you, the first rock is igneous. The second type of rock is a sedimentary rock. The third type of rock, we call it as a metamorphic rock. Suppose I saw here, I observed 2 things I observed. One is oceanic crust. Another one is a continental crust. In oceanic crust contains some rocks, which rock under the oceanic basis, most of the rock is made of basalt rocks. Which rock it is? Under the ocean, there is a basalt rocks are there. Which rock? Basalt rock are there. Under the continent, the crust is made up of which rock? Under the continent, the crust is made up of granite rocks. The crust is made up of granite rock. Granite is not as heavy as basalt. Granite is a lighter element, lighter rock compared to the basalt. Clear? Once again you have to see, crust is a outer layer of the earth. It has 3 types of rocks are there. One is the igneous, the second one is the sedimentary, the third one is the metamorphic rocks. Crust is divided into 2 varieties. One is oceanic crust, another one is a continental crust. Under the oceanic crust, there is a rock is there. That rock we call it as a basalt rock. Under the continental crust, there is a rock is there. That rock we call it as a granite rock. Granite is a lighter rock compared to the basalt one. Clear? This is the information about the crust. Now I am coming into the second layer. What is the second layer? Mantle. This mantle is the second layer of the cross section of the earth. It is the region lying between the crust and the core. Suppose you have to see, the outer layer is a crust. The inner layer is the core. Core is divided into outer core and inner core is there. They divided into 2, inner core and outer. This is outer core and this one is the inner core, right? So in between the crust and core, there is a region is there. That region we call it as a mantle. That region we call it as a mantle. How much thickness is there? 2900 kilometers thickness is there. This is very, very important. So many times your competitive people are asking the question, what is the thickness of the mantle? The thickness of the mantle is 2900 kilometer. This is the thickest of the earth detectable layer. This layer is very, very thickest layer, thickest of the earth detectable layers. It is made up largely iron and magnesium. It is made up largely iron and magnesium silicate. Iron silicates and magnesium silicates are there. It is made up iron and magnesium silicates. Though the rocks are normally solid, these rocks are normally solid, under long acting stresses, they tend to flow like a viscous liquid. Actually, it is acting as a solid, but because of the stresses and pressure and temperature, it can act as a viscous liquid like coal tar. Like coal tar, like that, this mantle can happen, right? Once again, you have to see what is the information about the mantle. Mantle is in between the crust and the core. In between the crust and core, how much thickness is there? 2900 kilometer thickness is there. It consists of the iron and magnesium silicates. It is the thickest layer, detectable layer. It is normally solid, but even though because of the long acting stresses tend to flow like a viscous liquid. The mantle can act as a viscous liquid. Clear? Now, I am talking about the core. The third one is core. This is very, very important. Suppose you have to see here, there is a two varieties of the core is there. The outer layer we call it as a crust. The outer layer we call it as a crust. After the crust, there is a layer is there. That layer we call it as a mantle. After the mantle, there is a core is there. That core, two varieties of core is there. One is outer core, another one is the inner core. Outer core, another one is the inner core. Now you have to see, the core, the central part of the earth comprises two layers. One is the inner core, another one is the outer core. First, I have to see outer core. This core I am seeing, outer core, which is the red part is there, no? That part I am seeing. How much thickness is there? This one is 2300 kilometers thickness is there, outer core. 2300 kilometer thickness is there. It lies beneath the mantle. It lies beneath the mantle. So, it lies below the mantle. As pressure of this region lower than the inner core, here iron exists in molten condition. Here which one is exist? Iron only will exist. In which region? That is a molten region. In liquid form, iron is existing in the outer core. Now I am coming into the inner core. It is having the diameter. Diameter means the depth from here to here or here to here. You have to take the ring like this. The depth or thickness 2600 kilometers are there. The thickness of the inner core is 2600 kilometers. The temperature of the inner core is, this is very, very important, 6000 degrees centigrade. That's why I told you in GS introduction class, plasma where existing? In the center of the earth, plasma also existing, because in the center of the earth, the temperature of the core is 6000 degrees centigrade is there. The pressure is about 3.7 million times as the atmospheric pressure at the surface. How much pressure is there in the surface, but you have to see that pressure inside the core. How much pressure is there? 3.7 million times more, right? Due to the enormous temperature and tremendous pressures, the inner core remains to be a solid state. This is very, very important. Inner core can act as a solid. Inner core can act as a solid, but outer core can form into the liquid, right? Outer core can form into the liquid. So please concentrate on these things. outer core it can act as a liquid, but inner core it can be acted as a solid. Why? Because enormous temperature and enormous pressure is existing. Due to the enormous temperature and tremendous pressure, the inner core remains to be a solid state. It consists mostly of iron, that lesser amount of the nickel. Which one is there? Iron, and lesser amount of the nickel is there, and nickel silicon, which accounts for the high density of the core. So due to these iron, nickel, silicon, there is a high density of the core. Density also very high is there. This is the information about the core. Now we are discussing about the layers of the earth. How many layers are there in the earth? 3 major layers are there. One first layer we call it as a crust. The second layer is the mantle. The third layer is the core, but core is comprising of 2 things. One is the outer core, another one is the inner core. Clear? Right. Now we are discussing about planet Earth supporting life has undergone a series of changes since its origin. Whenever the planet Earth formed, immediately human beings are not there, right? So many years takes place, so human beings exist on the planet. How it is existing, once you have to see. Geologists, based on the radioactive dating, it is a test to measure the age of that entity, that whatever the thing you have to, rock or wood or cloth, whatever the thing you have to take, that age when they made, that age you have to calculate because of the radioactive dating test. Geologists, based on the radioactive dating, estimated the planet formed 4.5 billion years ago. This is very important. Geologists assumed when because of the radioactive dating, when Earth is formed 4.5 billion years ago. But after 4.5 billion years, there is a theories are there. The first theory is dust cloud hypothesis theory. What is the dust cloud hypothesis theory? Whenever the solar system has formed from one of the huge clouds of dust and gas present in the universe, which acted upon by gravitational forces, got condensed more than 5 billion years ago. More than 5 billion years ago, our universe is full of, our solar system is full of consisting of the dust and gas. Our solar system full of consisting of which one? Dust and gas. Clear? Because of the gravitational forces, these gases and dust condenses, gas and dust condenses, and they can form as a dust grains clump into a planet symbols, and these dust grains can form into a planet symbol collides and collect into a planets. Today how the planets are there, such type of planets can happen. This theory we call it as a dust cloud hypothesis. What it gives? Dust cloud hypothesis. First, universe is making of the dust and gas. These dust and gases are, because of a gravitational forces, they condense. They can make as a planetary system or planetary bodies. Whatever the planets are there today, they are existing. The same planets can exist in this theory. Now we have to see, after forming the planet, suppose you have to see the planet is a dense material. Inside so much of the temperature and pressure is there, energy is there. But even though this dense one refrees into layers, layer 1, layer 2, now we are learning the crust, mantle, inner core, outer core, like that layers can form. Such type of process we call it as a differentiation. What is the differentiation? In mathematical, it is not mathematical differentiation. The differentiation means a dense material can change into the layer by layers, such type of phenomena we call it as a differentiation. Once you have to see the organization of the earth into layered state, we call it as a differentiation. During this process of differentiation, gases, water, vapor, primitive materials were liberated to form the atmosphere and oceans. Because of the differentiation, there is a gas are forming, there is a water is forming, there is a vapor trapped is forming, a primitive materials are formed, liberated from the formed atmosphere and oceans and seas, and all these things are forming. Earth differentiation, this is very, very important. After forming the earth differentiation, first there is two continents are there. When there is two continents are there, when there is two continents are there in 400 million years ago, 400 million years ago, Earth, two supercontinents, it has two supercontinents. One is in northern hemisphere, another one is in southern hemisphere. Suppose you have to take a zero line, equator line you have to take here. This north part, northern hemisphere, we call it as a Laurasia. This is very, very important. In UPSC examination also, people are asking what is Laurasia, northern hemisphere. In southern hemisphere, we call it as a Gondwana land. Earth is two parts. One is the northern hemisphere, another one is a southern hemisphere. In northern hemisphere, we call it as a Laurasia. In southern hemisphere, we call it as a Gondwana land. After 200 million years ago, this northern part and southern part make it as a one part. That part we call it as a Pangea. This is very, very important. After Pangea, there is a stretching because of the internal stresses and temperatures and high density and high energy. So these uniform body can stretch it out into a planet's continent. The supercontinent can you stretch it out the 7 continent, that is South America, North America, Africa, Europe, Asia, Australia, right? Asia, Australia, these continents are there. North America, South America, Africa, Europe, Asia, Australia, like so these are Arctic, Antarctic oceans also is there. Pacific Ocean and Southern Ocean, Indian Ocean and Arctic Ocean and Antarctic Ocean, like this. So many continents can formed after the stretching the Pangea. Once you have to see the theory, how we have to see. About the 400 million years ago, there was a supercontinent is called Gondwana land in southern hemisphere. Right? In southern hemisphere, there is a Gondwana land is there. And there is a supercontinent is there in a northern hemisphere that we call it as a Laurasia. Laurasia is a supercontinent in the northern hemisphere, and southern hemisphere there is a supercontinent is there, that is the Gondwana land. Till about 200 million years ago, the earth continents were bounced together into a single-use supercontinent. That single-use supercontinent we call it as a Pangea. Single-use continent we call it as a Pangea. Pangea by ocean floor probably broke up more than 200 million years ago. They formed in different continents. How they formed the different continents now I shown to you. Next, the cross section of the earth. Suppose you have to see one more theory is there. The cross section of the earth is consisting of a boiled egg like that. Boiled egg like that cross section is there. The density of the earth is estimated to be 5.5 grams per centimeter. This is very, very important. So many times your competitive people are asking this question. The density of the earth is estimated to be 5.5 grams per cc. That is the unit of the density. The crustal rocks are having an average density. This is the density of the earth. Please remember, the density of the earth is 5.5 grams per cc. If you will get the crustal rock density, the density of the crustal rock is, how much density is there? 2.8 grams per cc. 2.8 grams per cc, the density of the crustal rock. The deep interior contains mostly which material is there inside the earth? There is a iron is there, and a lesser amount of nickel also is there. Iron and nickel is there in the core. Suppose the picture of the earth interior might be compared to cross section of a boiled egg. If you have to take the boiled egg, there is a yellowish color is there, that is the yolk of the egg, and that is a white color is there, egg white we call it as, and then there is a shell is there, that is the cross section of the earth. This yolk it analogous to the core, and white analogous to the mantle, and shell analogous to the crust. 3 layers are there. That is very, very important. The yolk is the core, the white part it is a mantle, the white part, and the shell it indicates to the crust and outer part of the earth. Crust or outer part of the earth. This is very, very important once you have to see. Now, the interior core of the earth is very dense ball of the solid iron. Already I told, the interior core is become as a solid iron is there because it is a very enormous temperature and pressures are there. That's why it is a solid. The next layer is a outer layer. This consists of a semi-solid. Semi-solid matter means it is a viscous liquid consisting of the silicates, iron and magnesium is there. The next layer, inner core, it is the inner core, it is the which one? Solid material. The outer core is a liquid like that is there. It is a semi-solid material is there. That outer core is a semi-solid liquid material. Now you have to see here in this picture, you have to see the inner core. The inner core is a solid. The outer core is a liquid. Next, mantle is there. So above the layer is the mantle which contains the float. It is a viscous float like this is there. The mantle is a viscous float, right? Scientists worked out an accurate picture of the earth interior by studying the propagation of seismic waves. Seismic waves they are observing by sending the shock waves into the earth. By sending the shock waves into the earth, they are observing the seismic wave. The seismic wave nature, due to the seismic wave nature, they are observing the picture of the earth, how it is there, the picture of the earth. This is very, very important. Now you have to see the volcanoes. Nowadays, so many volcanoes are there in Indonesia. Daily one news is there, volcanoes are erupting. But in India also, some volcanoes are erupting in Uttarakhand, like that mountain areas, there is a volcanoes are there. What is the volcano? A volcano is a vent or opening in the earth surface through which lava or hot gases or rocks burst forth. Because of the whatever it may be is there on the earth, there is a lava, there is a gas, there is a iron or materials burst out. Such type of things we call it as a volcano, right? How many volcanoes are there in the world? 430 volcanoes are there in the world. This is very, very important. 430 volcanoes are there. The gases that are ejected from the volcano are principally steam, carbon dioxide and chlorine. These gases are releasing due to the volcano. Steam, carbon dioxide and chlorine. This is very dangerous. Large amount of the heat and pressure beneath the earth's surface cause the rocks to melt. Molten rocks release the gases maximum with magma. There is a magma is there inside the pressure and gas. Due to this, the rocks are molten. That molten part we call it as a magma. The molten rock material below the surface we call it as a magma, right? This magma when comes out through the vent surface is called it as a lava. This magma is come out to the surface, we call it as a lava. The temperatures of the lava are around 600 degrees centigrade to 1200 degrees centigrade are there. This is the story about the volcano. Once you have to see the picture, then you get the understand. First, under the earth there is a rock pot is there. Due to the temperature and pressure and the density, there is a rocks are molten. They can form as a liquid. That liquid we call it as a magma, right? There is a magma. It won't be stayed always inside the earth. It come on to outside. So this when it will come on to outside, when it is coming out, that term we call it as a lava. That term we call it as a lava. Not only lava, gases also will coming out. Now I told steam, carbon dioxide and chlorine also can form, can also created. So whichever the entry part is there, that part we call it as a crater, right? Once you have to see. Here three varieties of the terms are there in the volcano. First term is a magma chamber. Which one it is? Magma chamber. Molten rocks accumulated into a large reservoir. This is a molten rocks are liquefied. They are accumulated into a large reservoir. Such type of reservoir we call it as a magma chamber. After magma chamber, there is a central vent is there. Central vent. Once you have to see this part, we call it as a central vent. To come out this magma, there is a way is there. That way we call it as a central vent. The magma builds a channel through a weak point in the surrounding rocks and creates a opening. Such opening we call it as a central vent. Next, volcano eruption. How it will be volcano eruption? Molten rocks and fiery clouds burst out violently. Such type of bursts we call it as a volcano eruption we call it as. In volcano eruption, rocks formed from the solidification of lava, we call it as a igneous rocks. Then after solidifying the lava, such rocks can form igneous rocks. Igneous rocks can form. This is very, very important. There are three types of volcanoes are there. One is active volcano, is always erupting. Another one is intermittent volcano. It erupts at regular intervals. At time bound it will be volcanoes. A dormant volcano is one that it is temporarily inactive. Temporarily inactive volcano we call it as a dormant volcano. Because of the volcano, there is a lava is there. After cooling this lava, a fertile layer of soil can form. Once you have to see, volcanoes let come out. The energy that was built up beneath the surface, the cooled down lava, we call it as a fertile layer of soil can form. Which form? Fertile layer of soil can form. This is very, very important. Now, evaluation of the earth. Life on the earth. Evaluation of the life on the earth. You have to see. This is the Big Bang theory. 14 billion years ago, there is a Big Bang theory is there. Life began on the earth first in water about 3.5 billion years ago. This is very, very important. When our life can start, Our life can start on the earth 3.5 billion years ago on water. On water only this life are starting. All living objects originated from non-living material. This is also very, very important. All living objects originated from non-living material only. Simple plant-like organisms were the first, and gradually simple animals like organisms came into existence. From simple to complex, there is a theory can exist. First, simple plants can form. After only animals are forming. Directly human beings are not coming into the earth. First, plants. This is the evaluation. Now you have to see there is a protozoa and all those things, and plants and super corals and all the living creatures. Last human being. This human being is a intelligent person to control all the things in the universe, right? Fossil. What is a fossil? This definition is very, very important. The petrified remnant of the past life throw light on the life is the past. Suppose there is a fossil means shilajamu, fossil. How we are defining this one? Suppose wood we are cutting. After cutting the wood, so many days you have to throw it out in the sun. That entire the dried part or wet part is completely removed. The dried part is there. This part we call it as a fossil. The petrified remnant of the past life throw light on the life in the past. We call it as a fossils. How evolved? In the process of gradual change in the form of the life from the simplest organism in the past to highly evolved man of the present today. From past to present, plant to human being it in change. Who gave this theory? Darwin proposed the hypothesis that is a natural selection. This is very, very important. So Darwin theory, we call it as a natural selection. Darwin proposed the hypothesis of natural selection by which life may have evolved. Life may have evolved. Human beings constituted the pinnacle of the evaluation of life forms. Human beings are very, very principal, pinnacle, the most important part in the human beings. Now we have to see the questions. This is the theory. I told in this theory, what is the earth? How many layers are there? From inside to outside we have to see. What is the thickness and how the layer consisting of which material, everything we are learning. Right? Next, what we have to learn? How the volcanoes can form inside the rock, and that magma inside is there. If I come outside, it will become as a lava, and then lava solidification, there is a fertile land can form. Clear? Similarly, how the question paper pattern in your examination, once you have to see, the scientist who proposed the theory of evaluation, which scientist he proposed the theory of evaluation? By the selective natural selection, Darwin is proposed the theory of the evaluation. Now one more question you have to see. The petrified remnant of the past life is called as the petrified remnant of the past life, we call it as a fossil. This is very, very important. So many times your competitive people are asking this question. As we go deep into the interior of the earth, the pressure and the temperature changes. What will happen? Both the pressure and temperature are increases. If you have to go deep into the earth, the pressure and the temperature both are increasing. How much of temperature is there in the core? 6000 degree Kelvin temperature is there. So there is a huge temperature. The hot liquid rock material that comes out of the crater, we call it as a lava. The hot liquid rock, we call it as a magma. When magma comes out from the crater, we call it as a lava. This is very, very important. Now you have to see single earth, huge supercontinent We call it as a Pangea. Pangea is a single earth supercontinent. Gondwana land is the southern hemisphere supercontinent, and Laurasia is a northern hemisphere supercontinent. Clear? So these, like these questions are coming. This question came already in UPSC examination also. These are very, very important. So please choose this course. You have to join in this course. You will learn all the basic physics concept up to the 10th class level. Up to the 10th class level, all the basic concept. This course will helps you in DSC physics also. Over the people are preparing for the content only for physics, you have to choose this course. Thank you for choosing this course and learning the subject. Thank you very much.